Hello everyone, welcome to Civil Engineering and Stuff. And in today's video, we are going to discuss another type of distress in the flexible pavement, and that is deformation. So this is a part three of this broad topic. In the previous part, that is in part one, we have discussed in detail about the surface defect, and there we have discussed what are the different type of surface defect, that is fatty surface, smooth surface, sticking, and the hungry surface. Then in part two, we discussed about the crack defect, and there we have discussed about the variety of cracks that can happen on the surface of the flexible pavement, that is hairline crack, alligator cracks, longitudinal crack, edge crack, transverse crack, and the reflection cracks. So we have discussed in detail about these kind of distress in the previous videos. So if you haven't watched those videos, you can watch it after you are done with this deformation distress. All these videos are independent from each other. So like there's no conceptual apart from the basic understanding of the flexible pavement, there's no connection between the videos. So once we are done with the deformation lecture, you can always go and watch the previous videos. So continuing over the distress and the flexible element, today we are going to discuss about the deformation. Now, deformation, if we want to explain in a most simplest term, it is defined as the change that the flexible pavement goes apart from its or with reference to its original shape. So we have discussed about flexible pavement in detail in our previous lectures. Uh, There we have discussed the properties of flexible pavement, that is, flexible pavement as a whole, like does not contain a good amount of flexure strength. So that is why it is a formed in a as a multi-layered structure where the bottom layer is the subgrade, then we have the subbase, then the base course is there, and then the surface course, also called as the wearing course, is there, and together these layers work in homogeneity to provide the overall strength and durability to the flexible pavement. And if maybe due to any reason, maybe due to improper quality control, maybe the poor design methods, maybe due to not following the respective procedure while constructing the road, uh, as in when if the road is being subjected to load by the moving traffic, then any of the layer may undergo certain kind of deformity, right? Any layer may go certain kind of deformity, and that deformity is eventually seen at the surface of the flexible pavement. So as and when if we see any kind of deformity on the surface of the flexible pavement, or the reason can be any, then that is what we call as the deformation distress. Now, this deformation district may be restricted to either one layer or can be due to any of can be propagated to more than one layer, or it may arise because of the improper laying of any of the layers. For example, if soil subgrade is not being compacted to its maximum dry density, or the necessary treatment if required by the subgrade has not been done, then what will happen is that, in fact, even if we have a poor drainage along the flexible pavement, then the subgrade will tend to the overall integrity of the subgrade layer will basically decrease. And because of that, what will happen is the deformation in the subgrade level will happen. This deformation that happens in the subgrade level will eventually lead to the failure of the layer above it. Then this failure will propagate towards the surface. So this deformation may be restricted to any one layer, or can be due to the any of the layer of the flexible pavement. Now, the common type of deformation that can happen in the flexible pavements are slippage, rutting, corrugation, shoving, shallow depression, and settlements. So let's discuss about each of these deformations in detail. The first one that we are going to discuss is the slippage deformation that happens in the flexible pavement. Now, slippage is defined as the relative movement between the wearing course and the layer beneath the surface. That is, again, like the wearing course is the layer that is exposed to the moving traffic, and then we have below the wearing course we have the base course. Now, like during the laying of the different layers, proper connections between the layer may not have been maintained. That is, if some certain type code, prime code, seal code that need to be provided in different layers, uh, that has not been done. So like the proper bonding between the layers has not been done, because of which what will happen is, as the flexible pavement is subjected to the moving traffic, because of the stress that is being applied by the moving wheel, the wearing course will start to slip along the movement of the vehicle. Okay, and which will give rise to the slippage failure. This slippage deformation is characterized by the formation of crescent-shaped crack and points in the direction of the thrust of the wheel of the pavement. So here in this image is an example of your slippage defect that happens in the flexible pavement. So basically, what has happened is that this is your wearing course, the layer which is subjected to the moving traffic. Now, because of the improper bonding and maybe because of the improper laying of the road, what happens is, as this road is being subjected to the moving traffic, and the tire is right here at this section of the road, because of the thrust of the tire, that is the tire is moving in this direction. So this part of the layer has started to slip along the surface, right? This layer, the material would have been initially laid here, right? But because of the movement of the vehicles, the thrust by the tires, this part starts to move, and this portion is now slipped to this portion. Okay, and this can be very well seen in the image here. You can see here that as this material has moved or slipped along the direction, you can see this part of the material has compressed, right? So you can see the increase in concentration of material here, and the slippage of the material of at this section. Now, the talking about the location of the slippage, the location is along the wheel path of the vehicle, and mainly because of it happens because of the extremely heavy vehicle. So, wheel path of the heavy vehicle. What is the cause? The cause is the unusual thrust of the wheel in a specific direction due to omission or inadequacy of the tag coat, lack of bond between the wearing coat and the lower layer caused by the layer of fine dust, moisture, or both. That is, this means that definitely, like, this is now cleared to all of you, that it happens because of the thrust of the vehicle, right? As the vehicle moves, so this the because of the shear stress, the slippage of the layer will take place. Now the reason for this is, first of all, like a proper coating, proper quality control has not been maintained at the bearing course. Then the material that may have been used in terms of mix, too much use of fines might have been there, or like during the laying of the wearing course, the laying has not been done properly, because of which this slippage scenario is coming out. Talking about the severity level of the slippage deformation, now the severity can be classified as the low severity and the high severity. Low severity slippage condition is when this slippage is confined only to section of the carriageway. Okay, we can see this slippage is only confined to this section of the carriageway. However, if this slippage can be seen all across the width of the carriageway, across the width of the road, as well as along the major part along the length of the road, then this comes under high severity. Now, how to treat the layer that is being affected by slippage? The best option is to remove that layer. Okay, the best option is to remove the wearing course and then lay out a fresh wearing course. This is specifically mandatory in case of high severity. In case the slippage severity is low, then what we can do is, we can remove that patch of area of the pavement that is affected by the slippage defect. Okay, so we can remove this portion, and then quality check has to be done at the layer beneath, that is at the base course, so that just to see that this failure has not affected the layer beneath. As we can see in the image here, there is a stagnant water right now, right, in this slippage area. So if this is a prolonged duration, and definitely the vehicles will move over this portion, so that this water will further, like the moving tires will further apply a high pressure, and this water will ingress into the base course, the layer that is below this bearing course. So if that happens, then it means that this damage has been now transferred to, or has percolated into the base course also. So definitely then much further portion of the, or one section of the wearing course and the base course has to be removed, and then again a quality check need to be done, and then proper laying or the required necessary treatment has to be done. If not, if it is only confined to the wearing course only, that is only it is the slippage has just started, and uh, upon the removal of this portion, we observe that the base course has not been damaged, then what we can do is we can simply provide a fresh course of wearing course right at the section that we have removed. Okay, so this was about the slippage defect. Moving to the next kind of defect, that is the shoving defect. Shoving deformation happens as a result of plastic movement between the bituminous layer. Again, taking the example, so we have the wearing course. This is your wearing course. Then we have the base course. So what has happened is that there is an improper bonding between both the layers. First thing is that, then because of this improper bonding, as and when the vehicle starts to move over this type of pavement where there is a defect in the quality control when we are laying the different layers of the flexible pavement, and as and when the vehicle starts to move, definitely vehicles will apply certain kind of shear stress. Now, since these both layers are not bonded together perfectly, so what will happen is down the line the bearing course will start to move in a certain direction. What we can say is that your shoving is a much exaggerated version of the slippage. Okay, so in slippage, a part of the wearing course may be affected, or it can be extended to a full length of the wearing course. Uh, Likewise, in shoving, what happens is there is a full movement of the layer itself, right? While in slippage, there was only part of the wearing course that was moving respect to the layer below. Okay, so this is an exaggerated version of slippage. Uh, Talking about the locations, again, the location is as a, like it can extend throughout the width, as we can see in the image here. You can see if the shoving is being seen all across the width and all across the length, right? So it is mostly characterized by full like this kind of deformation happens all across the length and the width of the flexible pavement. Reason being the simplest, that there is no proper bonding between the two layers, because of which there is a relative movement or a plastic movement between the two layers. Okay, so what we can say is that your slippage is the first indicator of the shoving. So if you let the slippage phenomena to happen for a prolonged period of time, then eventually you will see this shoving phenomena also being happening in the flexible pavement. Okay, now one big mistake in the quality control that is done while laying the two layers is that sometimes it may happen that that bonding tech coat or the prime coat has been applied, right? But what during the applying of these coating, one mistake is done is that proper cleaning of the layer has not been done. Okay, especially this happens in case of when the layer is overlaid. When we have the overlay layer. Overlay means that a new layer has been coated above the pre-existing layer. Okay, this is a pre-existing, like the road has already been constructed, and just to maintain the quality of the flexible pavement, the older layer at the wearing course was removed, and then a new layer has been casted over the pre-existing layer. Now, once it is done, during this, definitely some coating material to form a bond between the two layers has been done. But what during the laying has been done is quality has not been maintained. That is, this pre-existing layer contains certain amount of dust particles all across its length and width, and then over this only the layer of tack coat has been applied. Okay, over this only the layer of tack coat has been applied. So definitely once you do that, once you apply this tack coat over the dust particles, then what will happen is proper adhesion between the two layers will not be there. And then though this overlay layer is a new layer, it's a new layer and it was supposed to work for a certain period of time efficiently. But because of the improper quality control, right, at the joint of the two layers, uh, as and when this road is being subjected to the moving traffic, then slip this shoving and will happen. Okay, the shoving will happen. Now, what is the cause of this shoving phenomena? Um, if we talk about the first of all, the one of the major mistake can be in terms of lack of bond between the two bituminous layer, that is the layer above and the below. There is no proper bond. Then again the quality control factor comes into the picture. The stability of the mix has not been taken care of. We have the mix contain high proportion of fines, excessive binder has been used, or a soft binder has been used based upon the climatic with respect to the climatic condition, and the road is being exposed to extremely heavy traffic movement then it was designed for. So these can be the major cause of the shoving effect. Now, how to treat the pavement surface that is being affected by the shoving? We don't have much of the option but to remove the material that the area has been affected and use stable premix patch is being applied in the area where the part of the carriageway has been affected by the shoving effect. Okay, while if we have the full pavement that like here we have the full width and the length of the pavement being affected, then we don't have any other option but to mill out, remove the full layer and then lay out a new layer. Then the third type of deformation that can happen in the flexible pavement is the rutting phenomena. Now, rutting is the longitudinal depression or the grooves in the pavement along the wheel path. This can be seen here. So, what happens is, as and when the vehicle moves over the surface, wherever the wheels of the vehicle moves, it makes a certain amount of depression. Okay, you can very well imagine that the tires of the car or any heavy vehicle have moved over the surface, because of which that portion only has been depressed. Okay, you can see in the image. I think like here you can see the in the image here. This should be the level of the road, and you can see the depression here. You can see the depression here. So this kind of deformation happens along the wheel path. Now, what could be the cause of the rutting phenomena? The first cause can be the heavy channelized traffic and the overloading of the vehicle. This means that first of all, suppose you are constructing any road, and for that basically certain thickness of the road need to be assessed, and for that some traffic survey is done, and then based upon the service life that traffic is increased. Now, some mistake has been done during the anticipation of the number of traffic, or the traffic count is okay, but the load that the commercial vehicles are carrying is too much. Like that is overloading of the vehicle has been done, and as and when these are moving, so definitely the road is not designed for this much amount of heavy loading, and so down the line, this depression along the wheel path happens. That is the first cause. Second cause is the inadequate compaction of the mix. That is mistake in the quality control of the bituminous mix that has been laid. This means that either the mix design has not been not has been laid at the OBC, that is the optimum binder content, or the mix as a whole has not been properly made in like the proper job mix formula has not been used, because of which that this deformation has taken place, or the proper layers has not been provided. Like suppose the this is a national highway or expressway, then proper BC DBM layers has not been provided as per the desired job mix formula, or the machine that is laying these different bituminous layers, that machine is at fault. So all these defect, these slack in the quality control, all this mistake in the quality control while designing the mix, while assessing the traffic parameters, while the quality controlling, whatever mistake that has happened, improper mix design, lack of stability to support the traffic. So all these loopholes in the quality control leads to this rutting deformation. Then weak payment due to poor subgrade and inadequate design. Design parameters we have already covered. Poor subgrade means that the layer that is at the bottom, that is the subgrade layer. Here the defect lies. The subgrade may not have been compacted to its maximum dry density, or it may happen that the soil subgrade that was there may have required certain amount of treatment, and that treatment has not been done properly. Or if there is a poor drainage facility at the subgrade level, so definitely the moisture will come inside the subgrade, because of which subgrade will become weak, and which this weakness will definitely propagate into the layer above. Then use of softer bitumen with respect to the climatic condition in which the road is being laid and the traffic it is going to take up. Then intrusion of subgrade clay into the granular base course, or use of plastic fillers in the GSB, WBM, and WMM. On and all, poor choice in the poor choice of material, poor choice of mix design, and the slack in the quality control leads to the rutting uh, deformation in the flexible pavement. Now, talking about the severity level, the rutting can be classified as a low severity if this depression is 4 to 10 mm deep, and if it is more than 10 mm deep, then it comes under high severity level. For comparison, we have image here. You can see the depression here. Like here, the depression with respect to the level is this much, while here you can see the level of depression. So this is an example of your low severity, and this is an example of high severity. Now, what could be the treatment that can be done to once the payment is being subjected to rutting deformation? The first is that suppose the payment is being subjected to low severity rutting, then use of open grade or a dense grade premix patching material can be used to fill up this gap. Uh, if this is very heavy, the depression is at high severity level, then advice is to remove that portion and then lay out a new material. Um, Quality control is again a very important parameter. If you want to treat these wearing cores that have been subjected to rutting, you have to ensure that this is not just a surface phenomena. It's not like this defect is basically due to the top two bituminous layer. We have to ensure that this problem, the genesis of this problem, is not right at the bottom level. Okay, then we have to once we have decided what to be done, proper marking has to be done, and then that portion need to be properly treated. The fourth kind of deformation that can happen in the flexible pavement is the corrugation. Right, corrugation is the next kind of deformation that can happen. Now, corrugation is the formation of regular undulation across the bituminous surface. You can see the regular undulation. Okay, you can see the regular undulation. And this again is caused weakness in the lower layer is the reason for this corrugation. Now, the spacing may vary from 2 to 3 meters, and definitely it creates a discomfort to the drivers. Now, reasons, you see, if you like, if I want to summarize this deformation defect, like if I compare these kind of deformation defect with the other type of defect that we have discussed before, one thing you will notice that deformation is basically the reason for deformation lies in the quality control of each of the layer. So if there is any slack in the quality control of the layer beneath, then this deformation we can see in the wearing course of the flexible pavement. Okay, so the main crux, what we can say, is the main reason for the deformation as a whole uh, is the poor quality control. Now, this poor quality control can be in the form of poor choice of mix, that we have used, poor lay the like during the laying of the flexible pavement, we had done some mistake, or like during the design time also we had done some mistake, like we have not properly taken into consideration the thickness, and there is no proper bonding, and likewise. So on and all, the reason of the deformation is the improper quality control or poor quality control at the layers beneath, which eventually comes out and is seen at the surface. Okay, so lack of stability of the mix, excessive binder, high proportion of fines, too round, too smooth texture, too soft binder, faulty laying of the surface course, insufficient rolling, braking action. So this braking action is a cause that initiates these things, but the main reason is this. These are the main reason because of which these deformation happens. Now, how to treat these kind of this corrugation defect? So, if the surface is thin, so you can see here the corrugation defect is very less severe compared to the one here, right? So if the ripples are only 2 to 3 meters apart, then it comes under low severity. If this is more than 3 meters, then it comes under high severity. So the treatment again becomes the same. The first is that if possible, only the wearing course that surface where the corrugation is there, that patch has to be removed, and then we have to check for the underlying layer, that is the base course, to see if we have defect here. If not, then the layer can be properly compacted. If any flaw during the designing, or the type of binder or that we have chosen, or the mix design that we have done is, if any quality control has been left at that point of time, then of course then that layer has to be removed, and then a new layer has to be spread. Next kind of deformation that we have is the shallow depression. Now, shallow depression are basically the isolated low areas of limited size, dipping about 25 mm or more below the profile, where water will normally become stagnant. Now, how it is like here also a depression in the pavement can be observed, but how it is different from rutting? Rutting is the depression that happens along the length of the pavement, that is along the wheel path. As the wheels are moving, the depression is happening, while your shallow depression are only confined to a certain area. Okay, again the reasons are same as that we have discussed before. The quality control in any of the layer, if any quality control in any of the layers is there, if the quality control in any of the layer has not been done, then that will eventually be seen as the shallow depression. Now, so next question, that the question that may come into your mind is that quality control in the pavement surface is there, but why we are seeing only one patch? So this means this quality control has been in the form, let's say we are compacting the subgrade. Now one section has not been compacted properly, or if there is a seepage of water in the subgrade, then this the moving water, as the water moves because of improper drainage, this moving water is taking with it the soil particles. So definitely what will happen is that the soil subgrade will have certain amount of depression. So this depression will be propagated in all the layers, which will eventually be seen as the form of shoving. What is the cause? Settlement, definitely settlement. So how settlement happens, and that we have discussed, that's in soil upgrade, inadequate compaction has been done, or there is a movement of water. This move, moving water takes with it the silt particles, because of which certain section may see certain depression. Okay, this is again some areas where the shoving has been done, and then these areas has been treated. How treatment has been done? If the depression is shallow, then these depression can be filled with premixed material, open grade material, dense material, and then compacted as per the to level up the field. Okay, now you may say that this looks more like a pothole. It can we say shallow depression as a formation of potholes? No, we cannot say this is a pothole. Why? Definitely about the potholes we are going to discuss in the next lecture in detail. But you see, in pothole, what happens is that the material starts to remove because of the over exposure of a layer to the stagnant water. Okay, then because of this exposed layer with the water, the stripping of aggregate and the bitumen surface takes place, and because of that the aggregate starts to come out and we see patches of layer being removed. While in shallow depression, what is happening? There is a depression being caused in the flexible pavement. All right, I'll again repeat for a better understanding. In potholes, there is a removal of particles. Particles are the aggregates, and the both coarse and fine aggregates are being removed from the surface of the flexible pavement or the wearing course. While in shoving, what is happening is in shoving, depression is being there, depression is caused, right? You can see here, like there is no material that is coming out, but a depression is being at one section of the road is being seen. Now, why this depression is happening? This depression is happening because of the settlement at the at the layer below it. That is the there has been some mistake in the quality control of the layer that is below the wearing course, and because of this, the settlement has been seen. So these shallow depressions are completely different from the potholes. Then the next kind of or the last form of deformation that can happen in the flexible pavement is the settlement and the upheaval. So this means again a section of the road there is a irregular profile we observe. If we see any irregular profile, that we call as the settlement and the upheaval. Okay, so this here in this section we see settlement. Now you will say, sir, the same kind of image I have seen in rutting. So why not it is rutting? Let's compare both the images. You first of all, if you see here, there is no tire marks you can see. While if we see the rutting image, if we see the rutting image, you can the tire marks are clearly visible, right? Here also you will see these are tire marks that are like the trajectory where the vehicles was moving. You can very easily see. While in this what you're seeing is that overall profile of the road, overall profile of the road in certain section along the width has undergone certain amount of settlement. Getting the point? So here you are seeing certain settlement in certain section of the road. While if this section of the road certain elevation is seen, then it comes as the upheaval. Okay, and this you can see this is upheaval, then we have the settlement, then we have the upheaval, right? Upheaval, settlement, upheaval. Okay, so this depression is what we call as a settlement, and then this elevation, some when there's a rise in the payment, then it's called as the upheaval. Uh, what is the cause? Same quality control. Quality control is one of the main reason for the any kind of deformation that happens in the flexible pavement, right? Inadequate compaction and moisture in the subgrade, then inadequate pavement thickness. All these comes in the under the quality control and the flaw in the design and the laying parameters. Now, how this upheaval can be treated? First of all, one thing is clear that this settlement and upheaval indicates some inherent weakness in the profile of the flexible pavement, right? And So that defect or that weakness we have to first of all identify. So for that, if this settlement and upheaval is observed, then that section is removed. The layers are inspected and seen that if what could be the cause. Uh, and then the required treatment has to be done. This means that suppose there is improper or a poor drainage facilities, then the proper drainage facility need to be provided. Certain if proper embankments have not been provided along the width of the carriageway, then that need to be taken care of. If there's a flaw in the design of the flexible pavement, that is while we were doing the designing. The thickness, assessing the thickness, if we haven't estimated the traffic correctly, or like maybe due to any mistake the thickness is not as per the requirement, then again this settlements and the upheaval can take place. Okay, so and on and all, usually since it shows the overall weakness in the profile, the whole redesigning of the flexible payment system is usually suggested. Okay, so these are the various kind of deformation that happens in the flexible payment. I hope the lecture was clear and easy to understand. If you have any doubt or any suggestions, do share in the comment section. It will help us to improve the quality of the lectures. If there is any topic of which you want me to prepare a lecture, and again do write in the comment section. If you find this video useful, do like the video. Again, share your views in the comment section and share the videos among your friends, and consider subscribing to the channel, and do check out the other playlist for the different subjects that we have prepared in this channel. And thank you for watching. Have a nice day.